Okay, so let's go ahead and get started. So I can try not to make these videos too long. So there are several ways that you can solve a quadratic equation. The first one is graphing to determine where the graph crosses the x-axis. The second way is to factor. The third is the quadratic formula. And the fourth is completing the square. We're going to focus on the last 3 units, or the last 3 methods. So here are some steps to factor. There's a couple different ways to factor, but regardless of the way that you decide you want to factor, you always want to look for your GCF. And remember, your greatest common factor could be a number, or it could be a variable, or it could be both. And then we're going to factor it by grouping. We're going to essentially change it from 3 terms to 4. And most of you are familiar with the box method, and that is one of the ways that we are going to factor this semester. It's essential that you can find the 2 magic numbers, 2 numbers that multiply to a times c and add to b. And then the last thing we're going to do is take out our GCF from each group. Okay, so let's go ahead and get started. And we have our first few questions, which are over factoring. So in order to factor, the first thing you want to do for factoring is set it equal to 0. So we're going to do that by subtracting 2 from both sides. Okay, so when we do that, we have, Okay, sorry about that. So when we do that, we have x squared plus 3x minus 4 equals 0. Okay, so our a value is 1. Our b value is 3. And our c value is negative 4. So we need to find 2 numbers that multiply to be a times c, but add to 3, which is our b. And our numbers would be a positive 4 and a negative 1. Now, because a is 1, we don't need to go and make a box. We can go directly to our factors. Okay, that would be our factors. But because it's asking us to solve it, we're going to set these equal to 0. And we get x equals negative 4. And x equals positive 1. Okay, now let's look at our second one. And also, I always encourage you at some points to pause the video, try to work it out on your own, just to see if you remember how to do it. Okay, so when we look at question B has already been set equal to 0, so we don't need to subtract or add anything. Our a value is 1, b is 7, and c is 12. So we need 2 numbers that multiply to 12 and add to 7, and that would be 3 and 4. Okay, so that factors down to x plus 3 and x plus 4. Set those both equal to 0, and we get x equals negative 3 and x equals negative 4. All right, our last one has an a value of 2, so we will need to create a box for that last one. Okay, let's see how this green looks. All right, so when the first thing I want to do is multiply a times c. So that would be 2 times negative 3, and that would be negative 6. So I need 2 numbers that multiply to negative 6, but add to negative 5. And those numbers would be negative 6 and positive 1. So I'm going to create my box. So I'm changing it to a 4-termer. The 2x squared has to go here, and the negative 3 has to go diagonal. And you fill up the other 2 squares with negative 6x and positive 1x. So we're going to take out our greatest common factor from each row. Okay. And we get 2x plus 1 equals 0, and x minus 3 equals 0. And when you solve, our first solution is negative 1/2, and our second solution is positive 3. Okay, so sorry about that. Let's go ahead and do a couple more questions in our factoring. So let's look at this one here. The first thing you want to do is eliminate the denominator, and we're going to do that by multiplying everything by x. Everything gets multiplied by x. So that's going to give us 6x squared minus 5x. And then at the end, when you multiply by x, you just get a 6. We have to set this equal to 0. Okay, and now we need to find two numbers that multiply to a times c, which would be 6 times negative 6, but they add to b. So numbers that would multiply to be negative 36, but add to negative 5, and that would be negative 9 and 4. So we're going to make our box like so. 6x squared goes here, negative 6 goes here, and then we have our negative 9x and our positive 4x. We're taking out the GCF. So in the top row, my GCF is 3x. In the bottom row, it is positive 2. In my first column, it is 2x. In the second column, it is negative 3. So that means that the factors are 2x minus 3 and 3x plus 2. So our solutions are 3/2 and negative 2/3. And that is a 2. Okay. Now I know that E looks a little different, but it is still a trinomial. We don't have a greatest common factor. And I want you to look at the exponents, how they go down. They're all even. 4 to 2, 2 to 0. So we can factor this like we would a regular quadratic, even though this technically is not a quadratic because the highest exponent is not 2. So what we're going to do, however, is just like before, we're going to find our two numbers that multiply to be a times c and add to b. So they multiply to be positive 4 and add to negative 5. That's negative 1 and negative 4. Now the only difference is, instead of x minus 1, because we started off with a 4th degree, we're going to split that in half, and we're going to put these two factors, or these two numbers that we came up at the back. So we have x squared minus 1 and x squared minus 4. And I'm not sure if you remember this pattern, but these are both the difference of two squares. So that's going to factor down to x plus 1 and x minus 1. And this one is going to factor down to x plus 2 and x minus 2. Okay. So when we set these all equal to 0, our four solutions, because it's a fourth degree, would be x equals -1, x equals +1, x equals -2, and x equals +2. You could also say, that's a 2 over there, plus and -1 and plus and -2. All right, and our last one before we finish out this first one is over. We have two more questions where we are going to factor, and because there are four terms, we're going to actually factor using the grouping method. So this is already started out as the four terms. We don't need to find our magic numbers. We're going to factor by grouping. So in order to do that, we take our first two and put them in a group, and our second two and put them in a group. When I look at my first group, what is the greatest common factor that I can take out of x cubed and x squared? And that is x squared. So when I take out an x squared, that means I'm dividing these two by x squared, and I'm left with an x plus 1. My second group has a GCF of -1. So I'm left with x plus 1. Now, what's really important here is that you recognize that these match. Okay? They have to match. If they don't match, that means we did not take out the correct factor. So our first factor is the x plus 1. Our second factor is the GCF, x squared, and then the -1. So we have x plus 1. This is going to break down to x plus 1 and x minus 1. So our three factors are x plus 1, x plus 1, and x minus 1. This is a double root, and we'll talk about what that looks like on a graph a little later. But for now, we're just solving. So we have x equals -1 and x equals +1. You don't have to list x equals -1 twice. So let's do this last question. We're going to group. And again, feel free to pause and try. Group, take out your GCFs. So you can pause the video or replay the video at any time. So in that first group, I'm going to take out an x squared. Okay, so essentially I'm dividing those two terms by x squared. In my second group, I am going to take out a -9. So -27x divided by -9 is 3x. -36 divided by -9 is +4. And again, look at what we have here. Wait, I meant to pick highlighter. Notice that these match. Okay, so when we write our two factors, our first one is 3x plus 4. And then in our second group, we have x squared and -9, which is the difference of two squares. So we have x plus 4, x plus 3, and x minus 3. So x equals -4/3, x equals positive and -3.